Lesson number 20, daily summary. In this lesson, we learn how to factor the difference of two squares. We'll start by multiplying out a few products. First one is x plus 3, x minus 3. So we'll just go ahead and do FOIL or distributive here. So first times first is x squared. Outers is x times negative 3, that's negative 3x. Inners is a positive 3x. And the last is minus 9, and we'll combine the terms in the middle, which, lo and behold, cancel. Negative 3x plus 3x disappear, and we're just left with x squared minus 9. Okay, let's take a look at part B. Same deal. First, 49. Outers plus 7y. Inners minus 7y. Last minus y squared. Combine the terms in the middle, which again, they cancel. 7y minus 7y. Now we're just left with 49 minus y squared. And then finally, 2x plus 5y times 2x minus 5y. First, 4x squared. Outers, negative 10xy. Inners, positive 10xy. Last, minus 25y squared. Combining like terms. Again, the two terms in the middle cancel, minus 10xy plus 10xy. So we're just left with 4x squared minus 25y squared. Okay, so what is making these terms cancel in the middle? Well, it's that this x plus 3 and this x minus 3 are exactly the same as each other, except one of them has a plus sign in the middle and the other has a minus sign in the middle. And so that's why the 3x and the 3x were exactly the same as each other, except one had a plus and one had a minus. And so our pattern is that if you have exactly this format, it's written right here, actually a plus b, a minus b, same exact thing in both parentheses, except one has a plus sign in the middle and one has a minus, then that term in the middle is always going to cancel. And so if the term in the middle is going to cancel, then all we're left is first times first, that was the x squared, and then last times last. 3 times negative 3 is negative 9. Don't forget that minus sign. And so here's our little shortcut. A plus b, a minus b is really just a times a, that's a squared. And then you have positive b times negative b, that's negative b squared. So you could use this shortcut, I guess, instead of foiling or double distributing, and it would save you from having to do the outers and the inners because you'll know ahead of time they're going to cancel. So maybe in a problem it saves like 5 seconds or something. It's really not worth it as a shortcut in terms of multiplying things out. But it is worth it as a shortcut in terms of factoring. So instead, we're going to be given things that look like a squared minus b squared, and we're going to recognize, oh, wait a minute, we know how to factor things that look like that. We're just going to take the a squared, and we're going to put an a and an a, and we're going to take the b squared, and we're going to put a b and b, and then we know that that minus sign always came from 1 plus and 1 minus. And so this is called factoring the difference of two squares, and that subtraction is the difference. A squared, b squared, those are your two perfect squares. So let's see if we can use that formula here, part A. Factor x squared minus 64. Okay, so in order to factor, in order to decide if this difference of two squares new formula is appropriate, we're going to ask the same 3 questions. First question, is it 2 terms? Yes, x squared 64, 2 terms, as opposed to the ones that we tackled last class, which had this form, 3 terms. So is it 2 terms? Yes, it is. Are both terms perfect squares? Yeah, x squared is a perfect square and 64 is a perfect square. Dead giveaway. If it was 65, this would not be a difference of 2 squares, but that 64 is a perfect square. Last question, is it subtraction? Is it a difference? Yes, it is. And so if the answer to those 3 questions is yes, then you get to use this new formula. Again, the 3 questions, is it 2 terms? Are they both perfect squares? Is it a subtraction? 3 yeses means we get to use this formula. So in the first blank, in both parentheses, we're trying to build x squared, and you got to put 2 copies of the same thing, so that's x and x. In the second blank, in both parentheses, we're trying to multiply and get 64, but don't just factor 64 willy-nilly. You need to put the same number twice. So for example, don't put 32 times 2, even though that will give you 64, because if you do that, you will get x squared, and you will get minus 64, but your outer and inner terms will not cancel. You'll have negative 2x and positive 32x, and they will combine and give you some x's in the middle that you don't actually have. So don't do that. We said x, and we're trying to get 64 with 2 copies of the same number. That's 8 times 8. And then always plus and minus in either order. And that's our factorization. Part B. 100 minus a squared plus b squared, same three questions. Is it two terms? Yes. Are they both perfect squares? Yes, that 100 is kind of a giveaway that maybe this difference of two squares formula is in play. And then finally, is it subtraction? Yes. So 100 is the first thing I see. I need to put something in the first blank in each parentheses. Two things that multiply to 100, but they have to be the same thing. Don't put 25 times 4, but 10 times 10. And then I'm trying to build a squared b squared with two copies of the same thing. Don't put a squared b squared. That will multiply to the right thing, but your outer and inner terms will not cancel. You got to put the same thing in both parentheses, except 1 plus and 1 minus. So what is the same thing that you can multiply by itself to get a squared b squared? Well, it's a, b. And then finally 1 plus and 1 minus in either order, and that one's done. One caution, oftentimes I'll have students take this 100 and not like that it's first. They like the 100, the constant, to be last. And so they'll put the 10 in the second slots, and that is no good. You cannot do, if you do AB plus 10 and AB minus 10, and you multiply the last two things together, plus 10 times minus 10 is negative 100. That is not what you had. You had positive 100. So you don't get to choose the order. You need to be true to the order that's given to you. The number came first, the 100. The number is going first in the parentheses, those 10s. Okay, see, 3r squared minus 27. Is it two terms? Yes. Are they both perfect squares? No. 3 is not a perfect square, neither is 27. So this is not a difference of two squares formula. I don't even need to ask the third question about subtraction. But we do know that we can factor out the greatest common factor, and in fact, we should do that first, any kind of factoring problem. So what goes into both of these terms? Well, there's a 3. Is there r in both terms? No. 3 is the greatest common factor. So what's left? R squared minus 3 goes into 27 9 times. So we have correctly factored out the greatest common factor. But now we have actually a brand new factoring problem. Take a look at the thing in the parentheses, r squared minus 9. It's new. And we can ask the same three questions to see if maybe, just maybe, we can use the difference of squares on that. So r squared minus 9, is it two terms? Yes. They're both perfect squares. They are now. We don't have a 3 to contend with, and the 27, not a perfect square, became 9, which is a perfect square. And is it subtraction? Yes, it is. So this is the difference of two squares formula. So the r squared minus 9 becomes, two parentheses, r squared came from r and r. 9 came from 3 and 3. 1 plus, 1 minus in either order. I will highlight in yellow. These two yellow things are equivalent to each other, but what we have omitted, and we're not allowed to omit, is that 3 sitting in the front. It doesn't go anywhere. Just copy it down. So this one is completely factored. So we have a new obligation. After we factor out a greatest common factor, we then have to examine the new thing and see if we can factor it further. I suppose we should have done that even up here. Like x plus 8 was a new thing. It wasn't here, right? It was brand new here. Can you factor anything out of x plus 8? No, we can't do anything with x plus 8, and we can't do anything with any of these things in the parentheses, but it's worth a look. Part D, x squared plus 25. Is it two terms? Yes. Are they both perfect squares? Yes. Is it subtraction? No. So this one is not a difference of two squares formula. The greatest common factor is just 1. There's nothing to do here. 2 by 2 box isn't going to go anywhere. This one can't be factored. Last class we saw a very fancy word, irreducible. Your book uses the word prime. I don't really like that. I think prime applies to numbers, not polynomials. But if you put prime, I'll give you full credit. But can't be factored or irreducible is my preference. It's tempting. It's tempting to try, well, let's see, if we're going to do something in this format, x and x, 25 came from 5 and 5. Well, I need it to be plus, so I suppose that I'm making a plus and plus. That will give you x squared plus 25. But if you look at the outers and the inners, you'll get plus 5x plus another 5x. They don't cancel. You get a plus 10x, but you didn't have a plus 10x in here. So you can't factor it with x plus 5 and x plus 5. In fact, you can't factor it with anything. Okay, part E, x to the 4th minus 16. Here we go. Is it two terms? Yes. Are they both perfect squares? Well, 16 is, and x to the 4th is as well. X to the 4th is x squared times x squared. It is a perfect square. And is it subtraction? Yes, it is. So we use our new formula. X to the fourth came from 2 copies of x squared. 16 came from 2 copies of the number 4. 1 plus, 1 minus in either order. As I said, we have new things in parentheses. We need to examine them and see if we can factor any further. Let's look in the first parentheses. X squared plus 4. Is it 2 terms? Yes. Are they both perfect squares? Yes. Is it subtraction? No. X squared plus 4 cannot be factored. It's irreducible, and we can't go any farther with it. But let's examine the green, x squared minus 4. Is it 2 terms? Yes. Are they both perfect squares? Yes. Is it subtraction? Yes. So we can factor that second thing using our difference of 2 squares formula. I'm going to leave a little blank space there, and I'll factor the green right here. X squared minus 4. X and x. 4 came from 2 and 2. 1 plus, 1 minus. I'll highlight in green. This is equivalent to the other green part. But what I have not copied down, and I need to, is the x squared plus 4. It doesn't disappear just because it's not factorable. And so this is our final answer, completely factored version of x to the fourth minus 16. Okay, so some observations about dots, but largely these are just the 3 questions that we ask. You need 2 terms separated by subtraction, each of which is a perfect square. You can't use dots if you have a sum. Sometimes you have to use the difference of 2 squares formula twice on the same expression like we just did in part E. Okay, the next page talks about this problem here, negative 6x squared minus 15x plus 36. So I'm not going to go through you can read what's on the page here. I'm going to take a slightly different approach to this problem. Suppose that we wanted to factor this, doing the 2 by 2 box. I'm just going to start over from here. So the negative 6x squared goes in the top left. The negative 15x is the sum. And that plus 36 goes in the bottom right. And then the next thing to do is calculate this product. 36 times negative 6, I think that's negative 216, and then there's an x squared. So we're looking to fill in the blanks with 2 things whose sum is negative 15x and whose product is negative 216x squared. Now, I don't know about you, but I don't know my factors of negative 216 all that well. It's kind of an intimidatingly large number for me. If you can go through the trial and error process or just somehow find the 2 things that multiply to negative 216x squared and add to negative 15x, you'll be good. You can fill in the blanks and proceed with the box method as usual. But I'm actually not going to give you one where you have to fiddle around with a number like negative 216. Instead, I'm going to give you this advice. Number 6, we have finished learning factoring techniques. Here is the order in which you should look to factor. Always, always, always this order, no matter what kind of factoring problem I give you. Number 1, factor out the greatest common factor first. Only after you have done that do you go to number 2. See if you can use the difference of 2 squares formula. Only after you have done those 2 things do you go to number 3, which is the 2 by 2 box method if you have a standard looking trinomial, 3 terms. So let's take a look at this problem right here that's highlighted. Again, the first kind of factoring is always the greatest common factor. So negative 6x squared minus 15x plus 36. Let's factor out the greatest common factor. So what number goes into all 3 of these numbers? Let's see, I guess 3 goes into all of them, and I think that's about it. So we'll take a 3 outside, and that leaves us with negative 2x squared minus 5x plus 6. Okay, and now we have a brand new thing inside the parentheses. And so we look at this brand new thing and ask ourselves if we can factor it further. So you can't factor out any more greatest common factor because you did it. You did the greatest common factor. So you'll never have to do that twice if you truly pull out the greatest common factor. Is it a difference of 2 squares? Because that's our second factoring technique to consider. No. It's not 3 terms, so right out of the gates, it is not a difference of 2 squares. And only after we've exhausted those 2 simpler factoring techniques do we consider the tough one, which is the 2 by 2 box method. But this one does factor using the 2 by 2 box method, so we're not going to do the whole thing out, but let's just get it started right over here. So we know that the negative 2x squared goes here. We're ignoring that 3. That's just going to get copied in the final answer. The negative 5x, that's the sum. The plus 6, that goes in the bottom right. And next step is to find the product on this diagonal. Negative 2x squared times positive 6, that's a negative, I don't have space here, but negative 12x squared. Product equals negative 12x squared. And now this detective game is a whole lot less intimidating to me than the one with the negative 216x squared. Here we're looking for two things that multiply to negative 12x squared and add to negative 5x. And that's a lot more manageable, at least for me. And so that one I would have a way to get started on. We could just, in an orderly fashion, list all of the things that multiply to negative 12x squared. I think there's only a dozen pairs that do that. And one of them hopefully gives us this negative 5x. And pause the video there because as I was saying that, I was floundering around in my mind trying to find the pair of things that multiply to negative 12x squared and add to negative 5x, and it does not exist because I goofed. I'm sure you saw it way back when. You should have told me. This plus 6 was no good at the very end here. Let's try that again. 3 goes into 36 12 times. So that means plus 12 right in here. And that changes our product here. So now we do 12 times negative 2x squared. So that's a negative 24x squared. Okay, it's bigger than it was before, but still not intimidating. I can list the factors of negative 24x squared. And indeed, there are two factors of negative 24x squared that add to negative 5x. I won't spoil it for you. You can find them on your own. But factoring out the greatest common factor, always the right first step. It prevents you from having to do the box method on something crazy like the negative 216x squared. Okay, and I think that's it. So again, just keep in mind the order here in number 6 and number 7 says if you need a refresher on the 2x2 box method, it's on the next page with an example problem worked out next to the step-by-step procedure. Again, the box template will be provided in activities, but not on the tests or quizzes. So you should make sure that you maybe bring that on your reference sheet if you are able to bring a reference sheet into the test or quiz.